In this video, we are going to do some 20 MCQ questions from the chapter refraction. On the topic refraction of light, the chapter name is light, refraction and reflection. So let's say begin with the first question here. As I see the first question, what does it says? It says which of the following act as a, the question says which of the following act as a rarer medium. So what you should know that whenever air is heated, right, it always rises. So hot air has, the region which is hot has a lower density of air. So we say that it has lower refractive index, or we can say that it acts as a rarer medium. One more time, let's say if I make a zone here, and this is a hotter zone, and this being cooler, right, then you'll say that over here the density of air is less, and therefore it should act as a rarer medium, and this cooler area should act as a denser medium. As of now, we have to find out the one which is they are talking about is which of the following act as a rarer medium. So we'll say that hot air acts as a rarer medium. Let's do the next. In the next question, it says the temperature of the material medium through which the light travels, the refractive index of the medium, right? So let's say if I take one small portion, right, where the this has a is hotter region, right? Let's say this be a hotter region. So on this is a medium where I have increased the temperature. What you should know that on increasing the temperature, right, if the ray of light passes through in this medium, this act as a optically rarer medium, and you should know that the speed of light will increase. The speed of light will increase. And the reason, as I said, that on increasing the temperature, the refractive index of the medium decreases, and we know that lower the refractive index, higher is the speed, and therefore the speed of light increases. The next question is says when a ray of light travels from optically rarer medium to optically denser medium, right? The ray refracted. So, like the previous case, for example, if I take, I'm taking a glass slab that should act as a, so glass slab, and I'll take, say, this being the incident ray, this being the incident ray here. And let's say if I make a normal over here, what you should know that in case of an undeviated ray, it should have gone straight, but you should know that as it is moving from an optically rarer to optically denser medium, it should bend towards normal. You see, it is bending towards normal and not away from normal. Well, that's an easy question. That's a basic bend towards normal is the correct answer. Well, normal, needless to say, this is what the normal I made this line perpendicular to the surface or refracting surface is called normal. Now in the fourth question, it says if the rays of light strikes perpendicular to the surface of the refracted ray. So let's once again make a glass slab only. I made a glass slab here, and I'm making a ray and making it strike the surface perpendicular to it, right? So you should know this ray so drawn here is actually is along the normal, right? It is along the normal. Maybe the two rays are coinciding. You can see here these two rays are coinciding. So what you will say that in this case the refracted ray will go undeviated. That is the refracted ray will go undeviated. There is no bending will takes place in this case. So one more time, what you can see here that the angle of incidence should be zero. Why did I say so? This is because the incident ray is coinciding with the normal. So two rays coinciding means the angle between them is zero. So since the angle of incidence is zero, so will be the angle of refraction, right? And therefore you will say that this will go undeviated. So this is bends, the question is options are bends away from normal, not correct. Bends towards normal, not correct. Traces the same path. Yeah, that should be correct. Traces the same path means it's not retracing, it's traces the same path. That means it is going undeviated, right, without bending. So therefore, as for the option, the correct option is traces the same path. Moving to the next. One more similar question, as I can see, it says when a ray of light passes from a denser to a rarer medium. This time it is denser to rarer. So let's say I'll take the glass slab. That's the best example to take. So this glass, this is a glass, as you know that this has high refractive index. Let me draw the whole path. First of all, I'm drawing a normal here that is perpendicular to the surface, and then I'm drawing an incident ray falling obliquely with some angle. As you know that when a ray of light travels from optically denser, rarer to denser, it bends towards normal. So it's bending towards normal is what I made here. Now I'll make another normal here. Let's say I made this normal over here. It should be perpendicular. Now what will happen to the emergent ray? The emergent ray is will bend away from normal, right? You can see it's moving away from normal and not towards normal. So as you can see, this is a denser medium. This is denser medium and this is a rarer medium. So you can figure out that when a ray of light travels from a optically denser to optically rarer medium, it bends away from normal. So away from normal, what is the question? When the ray of light travels from denser to rarer, its path is inclined away from normal, right? Inclined is what? Bends away from normal. So this is the correct option in this case. The sixth question says the refractive index of different layers of atmosphere is different due to the change in, well, let's say if I draw this being our earth, and let's say if I make another concentric circle representing the what's that air, right? Atmosphere. You know that the denser air, due to gravity, heavier particles are near the surface, and as you go higher and higher above, its density decreases. Like, so it's keep on the density keep on decreasing as we go high above. This is because of the gravity. But what we are talking about is the refractive index. So clearly, uh, at this portion, let's say I name this point as say P, let's say this is P, and below this, this is Q, and let's say this is R. As you know that the thicker layer of the atmosphere is R, so R will has the highest optical density, and as you go above, the the density of the air decreases, and lower the air density means lower refractive index. Now check for the options here. Change in temperature is not the cause. Different gases is not the cause. Yes, different densities of the air. Right. So we'll say that C is the correct option in this case. The question number 7, it says an electricity pole observed through flame of a holy fire appears to be fluctuating. Well, this is one of the cause of atmospheric refraction. Let's say, for example, if I make a holy fire, right? This is a holy fire over here, and I erect an electric pole over here. Let's say I erected one electric pole over here. Now, and say you are observing from here. Let's say I make a white ray. This is you, and you are observing from here. What is expected to happen that the light ray coming from this pole, as it travels, this is a cooler air, and as it enters through this, or maybe above this also, let's say you are moving from here, so this is cooler air, that means higher refractive index. As the ray of light travels from this zone, it has lower refractive index because hot air rises up, so it has lower refractive index. And again, as the ray over here is again cooler, so it will have higher refractive index. So you can see that as the ray of light coming from this pole to your eyes, say you are standing over here, the observer, you may figure out that these rays of light will continue to change its bending because of the changing refractive index. Let's see the option. What does it says? And that causes that's called, what do we call this as? Apparent fluctuation. Yeah? Something like that. So question is read now, and we are looking for the option. So continuous change in the direction of. Light from hot air to cold air. Yeah, that's true. So as the rays of light traveling from a cooler air to this hotter air and then to cooler air brings about the change in the direction of light. So sometimes the light may be appear to come from, sometimes the light may appear to come from this position, sometimes it may appear to come from this position, sometimes from this, and that gives the vision of fluctuation. Let's move to the next. So in the next question 8, he said Harshit is trying to observe the star of star in the sky and he finds that the position of the star is changes continuously. Well, it is talking about a small fraction of time. Do not get confused with the rotation of Earth and its revolution. That is different thing. Here they are talking about, let's say this being the star. I took this as the star here, right? This is the star. So what is happening here? He is talking about that it is its position is changing like this, right, changing like this. It's not that the other thing called the changing in position of the star due to the change in season, right? So what you should know that as the ray of light enters into the earth atmosphere, let's say I took this as our earth at let's say I took this as, where's that gone? Now, this being the earth over here, and let's say this is the air surrounding the earth. This is the air surrounding the earth, the atmosphere. As you know that the ray of light, as it enters into the earth's atmosphere, because of the different densities of air, right? Because of these different densities of the air here, the different densities of air, it keeps, and moreover this phenomenon through, or the air through which it is passing, its density keeps on changing because of change in temperature and other physical conditions. Like you know that during a day you might have experienced that sometimes wind blows faster, other times slower. So we have different temperatures during the day, and also during the night it keeps on fluctuating. So because of the changing phenomenon of this condition, physical conditions, temperature, humidity, wind speed and all, the apparent position of the star, which is slightly raised above, that does not remain constant. It keeps on changing. Sometimes it appears over here, other appears here. So yes, the correct answer should be what? Atmospheric refraction, right? So the atmospheric refraction, as I can see, is the correct. This is not scattering of light. Scattering of light is due to the particles, right? That's a kind of that's a when the rays of light get passes through the different size of particles. Dispersion is again not so. Yes, correct answer is this only. That is option B here. The next question is the colder layers of air present in the atmosphere is considered as dash medium. Well, questions are kind of repeat only. We have just studied about the cooler the air, cooler the air. What we can say that higher the optical density, and higher the optical density. Well, I think this much only we have to do. We don't need to proceed. So cooler air, uh, colder air layer of air present in the atmosphere are considered as optically denser medium, right? So next is 10th. The next question 10 it says stars appears to twinkle at night because of it. Well, you should know that the twinkling of stars, there are several phenomena involved here, right? One is the apparent uh, one star acts as a point source of light, and then second, the apparent position of star is slightly raised above, and there are something else we have to say. But what is the most important thing here? And clubbing all these factors together, we can say that it is due to the atmospheric refraction. It is the atmospheric refraction which gives an apparent vision of the star slightly raised above, and the changing density of the air uh, brings about the fluctuation, or the intensity of light entering into our eye keeps on changing. As you can see, intensity of light in entering into our eye keeps on changing, and that gives the, that's what, this twinkling of stars. So here it is caused because of the atmospheric refraction. So twinkling of star is caused by the atmospheric refraction. Well, next 11th one, it says, what happened? Just a second. Yes. It says the continuous deviation of light through the different layers of atmosphere is due to the well, continuous deviation of light through the different density of layers in the atmosphere is due to the refraction of light, scattering of light, atmospheric refraction. Yes, clearly that is atmospheric refraction, as we have done 2 3 times that. Let's say this be our earth, and you know that as different layers of earth atmosphere has different density, and therefore the rays of light gets deviated differently at different zone, and that's why whatever that atmospheric refraction caused because of this only the continuous deviations, right? It keeps on bending like this. Say if I show you the rays as it enters, then it bends again, then it bends again. So you see it is bending continuously like this, and that's because of the atmospheric refraction. Now we are on the last question. It says that the light emitted from the star travels from dash to medium. Okay, this some everybody knows that that the layer of atmosphere or the atmosphere what we know is up to certain kilometer, right? Let's say this is what the air present over here, right? And there is no air beyond this in the space. So therefore, if I say that this is a star and the star light is traveling, the star light is traveling like this. It is traveling in what? Vacuum, as there is no air over here. But as it enters into the Earth atmosphere, it faces the air. Air has slightly higher optical density than that of vacuum. This is vacuum. So we can say that the rays of light is traveling from options is, yeah, the first one only, the vacuum, from vacuum to denser, vacuum to rarer, rarer to denser is also correct. But this is not, this is a vacuum, so we do not consider its refractive index is considered 1, right? That's the reason we cannot take this option, and denser to rare is definitely correct. So the most appropriate answer will be this is vacuum over here, and then it is entering into air, and air acts as a denser medium in comparison to vacuum.